This video shows the replacement of a drive belt on a Nu-Tool HBS9-4 230mm two-wheel bandsaw. The background is that I was donated a non-functioning bandsaw and replaced the tyres on it and made a video of that. The good news is the replacement tyres are still working. The bad news is that the drive belt has failed and clearly a new one needs to be fitted. This video shows the installation of this replacement belt, and it's suggested that you watch the tyre replacement video first, which describes the removal and fitting of the saw blade in more detail. Just a reminder, this is a generic design that's rebadged by a number of suppliers, and the procedure for fitting new belts will be very similar for all of them. The first job is to remove the bandsaw blade, obviously making sure the power is disconnected. This is what is in the tyre replacement video, and some of it's repeated here for convenience. First of all, you need to start by opening the two latches. This is the top latch here. This is the bottom latch. And that reveals the top wheel and the bottom wheel, and on the right hand side you can see the chewed up drive belt which needs to be replaced. The first thing that needs to be done to remove the bandsaw blade is to use the knob shown on the right hand side of this picture to move the guide halfway between the head and the table. So you can move it up and down as shown by the double-headed arrow here. The next thing is to release the tension on the blade. Use the knob at the top of the wheel, arrowed here on the left-hand side, and unthread the blade. You can see actually the drive belt connected to the main wheel before it disintegrated. The picture on the right hand side has the drive belt identified, and the next stage would be to remove this. However, in this particular case the drive belt's disintegrated, so it's not really required. However, we'd need to be able to adjust the tension when fitting the replacement drive belt, so let's just do that now. The belt can be tensioned and loosened by using the two nuts that are identified by the yellow circles in the diagram on the right hand side. If you loosen these nuts, the top one is the pivot and the bottom one allows you to move the motor back and forth, tightening and loosening the belt. It looked like the removal of the bottom pulley wheel would simply be achieved by removing the circlip that looked like it held it on. However, it proved to be jammed on solid, and so the simpler solution was simply to remove the wheel from the axle by undoing the nut that's circled in the picture on the right hand side. This holds the axle in place and enables the wheel just to be pulled out on its axle. So here's the pulley wheel having been removed. You can see where the pulley axle would go. The belt drive cog is identified as well. There's the drive cog on the pulley wheel that's held on by screws. Here you can see the cog having been removed from the pulley wheel, and the nut that holds the axle in place is identified by the yellow circle. Obviously the cog needs to be put back on when reassembled. So when you reassemble the system, you want to place the drive belt around this plastic cog on the bottom pulley and loosely bolt the axle in place. Then maneuver the drive belt over the drive cog, which should be relatively simple because we've already loosened the motor tensioner. Once the belt centered on the cogs, you can tighten up the axle nut, tension up the belt, making sure the belt's still centered. Then you can check out the drive belt operation before fitting the saw blade, and the tyre video presented previously shows you how to fit the saw blade. So the next stage is to test the saw. So in summary, you see the drive belt is relatively easy to fit, and how long it lasts is obviously yet to be determined. Certainly hope this video has been helpful. It's one way of doing the job, not necessarily the best one.